All right, let's finish going over questions 4 and 5 from the Compound Events Google form that you guys completed. So for number 4, students are selecting Jolly Ranchers from a jar. There are 10 blue raspberry, 7 watermelon, and 8 green apple Jolly Ranchers. What is the probability that one student selects a watermelon Jolly Rancher and then a second student selects green apple? Now, what I want you to really take notice of in this question is they do not specifically tell us, hey, somebody's picking a Jolly Rancher and putting it back, or no, somebody's picking it and not putting it back. So they weren't really specific with us in this question, and sometimes that'll happen. Here's what I want you to remember. Unless the problem specifically says that something is being picked and put back, you have to assume that it's not. Okay, so once again, unless you are specifically told that something is being picked and then put back, you have to assume that it's not. So this problem has no replacement. And think about that too. That makes sense. If we were passing out Jolly Ranchers in class, okay, if the person next to you picked a watermelon Jolly Rancher for themselves to eat, they're not going to put that back into the jar before you pick, okay? They're keeping a Jolly Rancher for themselves, and that's exactly what's happening here. So we want the probability of the first student picking watermelon and then the second student picking green apple. So your total in the jar to start is 25 Jolly Ranchers. So if you add up 10 plus 7 plus 8, you get 25. So the probability of picking watermelon, there are 7 watermelon out of 25 total. So that's 7 over 25. Now remember, that first student is picking the Jolly Rancher and keeping it. So for the second pick, your total number of Jolly Ranchers has gone from 25 down to 24. When that second student goes to pick, there are only 24 total Jolly Ranchers in the jar. Out of those 24 that are left, 8 are green apple. So it's going to be 8 over 24. So multiply these fractions together. You get 56 over 600. Reduce that fraction to 7/75. Okay? All right, let's look at number 5. The numbers 1 through 16 are written on index cards and then placed in a bowl. What is the probability of selecting an even number? Returning the card, so that's important, and then selecting a multiple of 4. So in this problem, we do have replacement. They are specifically telling us that first card is being put back before the second card is picked. So if you have the numbers 1 through 16, you have a total of 16 cards. On the first pick, I want an even number. So if you need to, write out all the even numbers and count how many there are. So your even numbers would be 2, 4, 6, 8, 10, 12, 14, 16. So there are 8 total even numbers. And then on the second pick, I want a multiple of 4. So if you think about your multiples of 4, count by 4s. 4, 8, 12, 16. So there are 4 total cards that contain a multiple of 4. Okay, so the probability of an even number on the first pick, there are 8 even numbers out of the 16 total, so it's going to be 8/16 times. Now, when the second card is picked, because they specifically told us the first card is put back, my total for the second pick does not decrease by 1, it stays at 16. So my total for the second pick is 16. I want a multiple of 4. There are 4 multiples of 4. So it'll be 4/16. Multiply these together, reduce your fraction, you should get 1/8.